Hey everyone, so this is the review for Showcase of Learning 5. This is going to be pretty much how your Showcase of Learning is going to look. And so let's just walk through it. So same format, just different problems. All right, and to make this follow a little bit easier, I'm going to be using my map, which I need to find. And I've made a few little comments on there just to give you or trigger your memory. And so let's go ahead and get started. So below is a quadratic function given in three equivalent forms. We're going to graph this function on the axis provided, and we're going to label the important points, and we're going to tell which points you gained from each form. So we don't have to do any converting from vertex to standard to factored form because that part's already been done for us. We just have to look here and recognize that since it's in standard form that we can get the y-intercept, and that the y-intercept would be 0, 10, and I'm going to go ahead and graph these as I move along. So there's 0, 10. That this is in vertex form, which gives me the vertex, and the vertex will be 3 and negative 8. So I'm going to go right 3 and then down 8. And then in factored form, I can get the x-intercepts. So one of them is 1, 0, and the other one is 5, 0. So there's 1, 0 and 5, 0. And if you want to get that nice balanced view, then what you can do is through the vertex, draw that line of symmetry. And then while these have partner points, you can give this one a partner point over here. You don't have to do this. You can probably just see the U from those, how many are there? 4 points. And then you will connect your points to make the U shape called the parabola. Okay? All right, so the next question. So this is being phrased in a way that we aren't used to seeing, but we do know how to do this. So we're going to change this quadratic function, which right now is in standard form, and to the equivalent form that helps me see the x-intercepts. So, which I did not write up here, the x-intercepts come from factored form. So I will have to get this into factored form. And the way to do that, to go from standard form to factored form, is factoring. And just a reminder, always try the GCF. So when I look at 2x squared, 13x, and negative 7, there is not a GCF, so I'm going to go right into my x. I need factors of negative 14 that get me to 13. And those factors are going to be 1 and 14. And right now the 1 is negative. So I'm going to go to my parentheses. I'm going to drop in those x's. And right now x and x are not enough. That gives me x squared, and I need 2x squared. So I'm going to put a 2 with one of these. If you want to put a 1, remember it's invisible. I put it in pencil so I can erase it later. But it's 2 times 1 is the 2x squared. And now I can draw my loops, or my face, to make the side numbers. And 1 is never picky. It can make both numbers here. But 2 is. And so 2 can only make a 14x. So I'm going to follow this loop. And 2x with a positive 7 can make the 14x. And 1x, following this loop with a negative 1, can make the negative 1x. And then from there, I'll go for the x-intercepts. So I'm actually going to hold off on the x-intercepts and save that for the end, because there is a trick on one of these, and or there's a catch, I shouldn't say a trick. So we're going to save this one. Now question 2b just says identify the y-intercept for question 2a. So since this is in standard form, I should be able to see right away that my y-intercept is 0, negative 7. All right, question 3. This time we're going to change the quadratic function into an equivalent form that helps us see the vertex. So while we're starting in standard form here, to see the vertex, we'll need to get it into vertex form. And then we're going to tell what the vertex is, and we're going to write it as an ordered pair. So if I start with standard form, to get to vertex form, we're going to have this process of completing the square. So this is kind of a overall general look of what it looks like. So I start by grouping my x's together, and then I add a square, and then I'll take away a square. So remember, just the x's are in here. Now when we did completing the square, we only start with x squared. So I will have to GCF a negative 1 out of here, just the negative 1. I'm not going to take an x out. And that's going to leave me with x squared minus 2x. And then the rest I'm just going to copy. And now I'll take this negative 2, always cut it in half, that's negative 1, and then I'll square that number, which is 1. And so I'm going to put a 1 here, but now I'm going to ask myself, is it really worth 1? And so here comes the bunny hop, and it will say that negative 1 times 1, it's actually, even though I wrote 1, this is worth negative 1. So I'm going to bunny hop over here and make sure I put a negative 1 in here. And just a reminder of what vertex form looks like. And you could also look up here. This time I will have a number in front of my parentheses, so negative 1, it'll be x. And then in front of this squared will be the same number that's in front of this squared, so a negative 1. And then here, when I look for the number outside, I have to be careful because when you subtract a negative, that's like adding a positive. So this actually becomes negative 15 plus 1, which is going to give me a negative 14. And then this is a typo. It should say vertex. And so now I'm going to get my vertex, so it's going to be 1 and negative 14. And then, as before, we're going to go identify the y-intercept for question 3a. So going back to here, my y-intercept is 0, negative 15. All right, I have not forgotten about question 2a. We will come back to that at the very, very end. So here what we're going to do is we're actually going to graph. And so given one form, we will have to find the others. So right now, this is in standard form, which is going to tell me this y-intercept of 0, 10. So I'm going to go ahead and put that graph there. And now to get the other forms, it really doesn't matter which one I do first. So I'm just going to go ahead and get this into vertex form first. So I'm going to complete the square, put those x's together. So here's vertex form work. So I'm going to add my square, and then I'm going to subtract my square. And now I will take this number, cut it in half, which is 3.5. Yes, we do have a decimal. We can use a fraction or a calculator to help us. And then when I square 3.5, remember that's 3.5 times 3.5, which gives me this number. So that's the number I'm going to put in my box. And then I just want to make sure that it's really worth 12.25. And there's nothing to bunny hop with, so it really is. So I'll put that 12.25 here. And now for vertex form, there's no number in front. You can put that invisible 1 if you want, and x with this squared. And in front of this squared will be the number that's in front of that squared, and that's a positive 3.5. And now, to get the number outside, I'll do 10 take away this 12.25, which gives me, with the calculator probably, a negative 0.25. So my vertex is going to be, remember the opposite, that's our little trick, negative 3.5, and this one is not the opposite. So graphing this one is going to be a little tough to graph the decimals, so I'm just going to estimate. So I'm going to go left, negative 3.5, which I end up about there, and then I'm going to go down 2.25, which I'm just going to go barely past the 2 and just put it right there. And there's the y-intercept, and now what I need to do is find the x-intercept, which is going to come from factored form, and that means I have to use standard form because there's not an arrow that takes me here. So I will be factoring x squared plus 7x plus 10. So here's my x. I need factors of 10 that get me to 7. Those will be 2 and 5. I'm going to make those parentheses and drop the x's in and just make sure that x and x is enough. So x and x do make that x squared. I don't need anything else. I can draw the face to make these side numbers. Some of you maybe are still scribbling those out. And since they're both x, either one can get either of these. So I'll have x going with this loop. X times a positive 2 gives me this. And x with this loop, x times a positive 5 gives me this. So again, our trick is just take the opposite of what you see in here. So one x-intercept is going to be negative 5, 0, and the other one is going to be negative 2, 0. So now I'm going to come over here and finish up my graph. So y-intercept, vertex, negative 2, negative 5, and hopefully from there you can see the parabola because that's all you need. You don't want to draw on that axis or line of symmetry. And there's my u. There's my parabola. All right, one more, and then we're going to finish up with that question 2. So this time I'm starting out in vertex form. So right away I'm going to get my vertex. The trick is 4 and then -9. So I'm going to go ahead and go right 4 and down 9 and get that point first. And now I'm going to get my other form. So if I start in vertex form, the only thing I can do is get to standard form. And so if you remember, that squared means we're going to have to write those parentheses out. So the first thing you do is what's underlined, and that's why there's a 1 there. We're going to distribute the parentheses to each other, or if you're in my class, that's called the neighbors meet the neighbors. After that, if there's a number in front, then we'll deal with that A will multiply in, and then from there, the last thing we'll do is that number that's added or subtracted at the end. So what I'm going to do first is just write this out. And this is all work to get to standard form. So what I'm going to start with is the distributing, or the neighbors meet the neighbors. So x is going to meet or distribute, and we're going to get x squared minus 4x. And then this one's going to distribute or multiply, or whatever you want to call it, and there's a negative 4x. And then remember, the last set, the last terms, you are multiplying. So negative 4 times negative 4 is a positive 16. So now what I've done is this first step. If there were a number in front of the parentheses, I would take that number and then distribute it to all 3. But there's not, so what I'm going to do is the third step, which just reminds me to work with the number at the end. So I'm going to drop that down. And now I'm going to combine these like terms of 16 take away 9, and when I'm done there, I get 7. So there's my standard form. I can get my y-intercept now of 0, 7, right there. And now the final thing I'm going to do is get the x-intercepts, which the x-intercepts are going to come from factor form, which can only come from standard form. So I'm going to take this one, make my x, and I'm going to get factors of 7 that give me -8, and those will be 1 and 7, with both of them being negative. I'm going to make my parentheses and drop my x's in, and I'll just double check, is x times x enough? It is, it's x squared. And then to get these side numbers, we'll do the loops, or the face. And since they're both x, I'll let this x multiply with a -1 to make -1x, and I'll have this x multiply with the -7 to get the -7x. And now my x-intercepts are 7, 0, and 1, 0. So I'll come over here, here's 1, 0, here's 7, 0, and hopefully you can see that parabola. Remember, if you can't, draw that line of symmetry through the vertex, and then you could get this one's partner point, and these are already set, and then you could make your parabola shape. All right, the last thing I want to talk about is question 2. And right now, what's going to happen is when you are asked for the x-intercepts here, I'm going to erase this invisible 1. We can use that trick, just take the opposite. And so one x-intercept is -7, 0. So what's going to happen is most of you are going to come over here and say, yep, the opposite is 1, and make this one 1, 0. So what I've been showing you is a trick, and the trick is nice, but the trick doesn't work every single time. It only works when you have your parentheses if what's in parentheses is x plus or x minus a number. So all of these are x plus or x minus a number. And when it's in that format, we can do the opposite. The reason that trick works is because what I really want to know is what number, if I put it in for x and then subtract 3, would make these parentheses become 0. And this 3, if I put it in there for x, 3 take away 3 is 0. Or if I put this 1 in here, 1 take away 1 is 0, or 5 take away 5 is 0, and thus -7 take away, or adding to 7 is 0. But when you put 1 in here, that's 2 times 1, which is 2, and 2 take away 1 is not 0, it's 1. So what I really should be doing is looking at what will make these parentheses, what will make x minus 3 equal 0, what will make x minus 1 equal 0, what will make x minus 5 equal 0, and in this case, what would make x plus 7 equal 0. And then you can go back to our very first chapter of solving, where we have to, I would draw the wall, and then we would work to get x alone, and then to get x alone, since they add 7, I subtract 7, and then I get the x value of the x-intercept, -7. So if I do the same here, since they subtracted 3, I'll add 3, and so I get the x-intercept, or of the vertex, sorry, the x value of the vertex, or if I add 5, I'd get those other numbers. So here, the shortcut is not going to work. I will actually have to see what will make these parentheses, 2x minus 1, equals 0. I'm going to draw my wall and work to get x alone. So the first thing I'm going to move is the addition subtraction. So since subtracting 1 is happening, I'm going to add 1, and then I get 1. And now to move the 2 over, since these are multiplying, I'll use division. Those cancel out. And so the value for my x-intercept isn't 1, it's actually 1/2. And if you do put 1/2 in here, just like you put -7 in here and get 0, if you put 1/2 in here, 1/2 of 2 is 1, and then 1 take away 1 is 0. So that is a little catch, and it hasn't happened that much, maybe twice so far, but that is definitely going to happen on the Showcase of Learning. So just to prepare you. And that is your review.